I want to talk about today one little piece of the quadratic formula that is known as the discriminant. The discriminant is just one part of the quadratic formula, one part of this formula. X is equal to opposite b plus or minus the square root of b squared minus 4ac all divided by 2a. And this discriminant tells us an interesting piece of information. So let's set up our discriminant, look at what we see when we find the discriminant for a variety of quadratics, and then look at how we can use that in some problems. First of all, let's define several quadratic equations. Let's start with x squared plus 5x plus 8 equals 0. There's 1. And then we will do negative 9x squared plus 12x minus 4 equals 0. And let's make our last one x squared minus 5x plus 4 equals 0. So we have a series of quadratic functions that we've defined. Let's make sure they all show up on our screen. And then let's talk about what that is going to do for us if we find the discriminant and what the discriminant is. All right, first of all, the discriminant is defined as this portion of the quadratic formula that's underneath the radical sign, b squared minus 4ac. It is that value that we get when we plug in our a, our b, and our c into the quadratic formula, but it's just the part under the radical. It does not include the radical sign itself. It is only what is underneath of the radical. So let's find the discriminant for these three quadratics. If we look at this first one, a is equal to 1, b is equal to 5, c is equal to 8. So our discriminant here would be equal to the value 5 squared minus 4 times 1 times 8. And if we calculate that all out, we end up with a discriminant of negative 7. In the next one, our a is equal to negative 9, our b is equal to 12, our c is equal to negative 4. So our discriminant here is equal to 12 squared, b squared, minus 4 times a, and a is negative 9, times c, and c is negative 4. And if we calculate that out, we get 0. So our discriminant for that second quadratic is 0. And then for the last one, the discriminant is equal to b squared, so negative 5 squared minus 4 times a times c. And if we calculate all of that, we get a discriminant of 9. So at this point, I want to make sure that we understand what that is going to do for us, what it's going to tell us. And so I'm going to make 3 really quick sketches. If you graphed these on your calculator, and these are in no way what I would consider to be a good graph, but it will let you see the one thing that we are looking for. If you graph that first quadratic, you get a graph that resembles this. If you graph the second one, negative 9x squared plus 12x minus 4 is equal to 0, you get a graph. When you graph it on your calculator, or you find some points and graph it by hand, that looks like this. And if you graph, that's the second one there, if you graph this third one, your graph looks like this. Now I'm betting that some of you, as soon as you see those 3 graphs, can figure out the meaning of the discriminant. In this case, our discriminant was a negative number. B squared minus 4ac was less than 0. Or we can say that another way and say that b squared was less than 4ac. 4ac. We don't usually say it that way, but we could. But b squared minus 4ac was less than 0. It was a negative number. In the second case, b squared minus 4ac was equal to 0. So in the second case, we got a discriminant of 0. And in the last case, b squared minus 4ac was 9. It was a positive number. It was greater than 0. So look what this tells us every time. If we compute our discriminant for any quadratic, if we get a number that's less than 0, if we get a negative number, look what happens to our graph. It never crosses the x-axis. There are no real solutions to this quadratic. It's not going to give us an x-intercept. It's never going to cross the x-axis if the discriminant is a negative number. And here, when b squared was equal to b squared minus 4ac was equal to 0, look what happens. It touches the x-axis, but only one time. There is one real solution if the discriminant is equal to 0. So now let's use that logic and see what happens when our discriminant becomes a positive number, as it did in this last case. B squared minus 4ac was greater than 0. What do we end up with? We cross the x-axis twice. We have two real solutions to our quadratic. That discriminant can be used for a variety of things. It can tell us if we reach different values. It can tell us whether or not we're going to cross the x-axis. And we'll look at what happens when we don't get any real solutions in the next video. But value of the discriminant, this piece of the quadratic formula that's underneath of the radical, if it is a negative number, you don't have any x-intercepts. You have no real solutions. If it's equal to 0, that means we didn't have anything in this plus or minus on this function over here. We got nothing there. So we just had the negative b over 2a. We have one real solution. And if this turned out to be a positive number underneath of that radical, we know we have two real solutions. This is the discriminant of a quadratic.